Hello and welcome back. In this session we will explore how to use abstract class and interface together in C#. These two powerful features allow you to design systems that are both flexible and organized. We will create a hybrid example combining abstract and multi-interface. So, why are we gonna use both abstract class and interface? Before we're gonna dive into the code, let's quickly recap. Abstract class gonna allow partial implementation. Method can have body. Plus support inheritance, providing a shared functionality to derived classes. On the other hand, interface define a contract for class to implement. Enable multi-inheritance, allow a class to implement multi-interface. Let's build a system for smart applicants. We will define an abstract class applicants with shared functionality and two interface for switchable for power control and controllable for remote control capability. The first step here, I will start by defining the abstract class, which include shared properties like name and method for displaying details. So I will start from here by saying abstract class applicants, and inside that one we will start by having a property. That one will call it name, and the type of it will be string. I prefer the property to start with capital letter. Then let's have our constructor. As we agreed, gonna be CTOR, and then press tab. It will directly provide you with the constructor. We're gonna make it public, and this constructor, it will have a parameter of name. Then we will pass the property to the parameter. Great. After that, let's have here display details. So it will be public void, and we're gonna say here display details. That one will not accept any parameter. No need for parameter, and it will have basic implementation for this method. We're gonna say here applicants like this. Let me put here double quotation applicants, and here is the name of the applicants itself, which it will be our property, and no need for all of this, just like that. And after that we will close our double quotation. Then after this we will have another function, but this time it will be just without any implementation. So it will be public abstract, and after that we're gonna have a void as a data type, and we're gonna call it perform function, and it will not have any parameter. And that one, as you can see, it's just abstract method for applicants specific functionality without any body. So next we will define right now two interface. I will start by defining the first one, interface. We will give it a name switchable, and that interface will have two methods, just void turn on and turn off. So I have this one as a copy, and we will put it here. It will be turn off. After that we will define another one, which it will be controllable, and that one just increase setting and decrease setting. And now let's go and create two classes, smart fan and smart light. Each class will inherit from the abstract class to see how we're gonna work with it, and he must implement both switchable and controllable. Let's do it together. So from here we're gonna say class smart fan, and from here we're gonna say applicants as an abstract class. He's gonna inherit, and he will implement switchable and controllable. So as you can see, it directly give you like an issue here and an issue here. If you're gonna click on this one, he's gonna ask you to implement the interface. We're gonna do like that, and same apply for the iSwitchable. We're gonna click on implement an interface, so he will give you this one straightforward. But let's start by defining one property for smart fan. Smart fan gonna just have a speed, so we're gonna say here a property. That one speed gonna be integer. I'm gonna set here setter and getter. And for the smart fan constructor, we will add here a constructor which is gonna be public smart fan, and that constructor will have string name, and that one gonna inherit from the base class name. Then we're gonna put initial value for the speed, gonna be just 0 as initial value for speed. So definitely that speed gonna increase, so we're gonna put here speed plus plus, and inside decrease it will be if condition. If speed is greater than 0, we're gonna say speed minus minus. Yeah, close that one like that. So no need for through, and no need for through this one as well. And inside the turn off, we just gonna set here a print message for both of them. This one gonna be turn on now, and that one gonna be turn off just right now. And what else we would like to implement here? We're gonna have even a print message for the increase, which is gonna be straightforward here. Speed gonna be decrease for that value, and here increase for that value. Next, we will apply the same with the smart light. So here it will be class smart light, and that time that one gonna inherit from applicants, and gonna implement iSwitchable as interface, and gonna implement iControllable. Then we will do the same for this class to speed up the process. I started by defining a property called it brightness, and definitely this brightness gonna start with the value 0, same like what we did with the speed. So that one gonna start with value 0. And for the smart light, for the name, it will string name, and that one inherit the name from the base class. After that, we would like to implement iSwitchable and iControllable, so we're gonna do the same here, implement, and the same for this one. And I did the same here, turn on, and even I provided the print message here, and same here for the increase gonna be brightness plus plus, and for decrease the brightness gonna be minus minus in case that brightness greater than 0. And have a look here, we still here have an issue because smart light doesn't implement inherited abstract member that call it perform a function. That's why you're gonna click here and gonna click implement abstract class, which is gonna directly use override keyword with the perform function. And let me check over there if we did the same or not with that one, with the smart fan. Even we didn't implement the abstract class, so we're gonna apply here the same. It's gonna be use override keyword to implement the abstract method for the perform function. And that one doing nothing, just a print a message that this smart light gonna be just lightening, and the same for the fan, it will not do anything, just like the fan gonna be spinning. And finally, let's create a list of applicants object and demonstrate the functionality of our smart applicants using both abstract class method and interface method. So if you're gonna scroll down here, we will find our main, and inside the main method we define it a list of applicants, and we have here two kind of objects. The first one gonna be smart fan, which gonna have a name living room, and smart light gonna be a bedroom light. And here we used the for each to loop on the applicants inside the applicants list. And the first time the applicants gonna display the details. Let me have a look and execute this application in meantime. So if you're gonna check here beside that one, we can find here applicants display name. It's gonna start by living room fan. Then for the perform action, it's gonna say, okay, this fan gonna be spin. And here if the applicants is eye switchable, so here it's gonna be turn on, as you can see. So gonna say here turn on, turn off. And in the meantime we're gonna check if applicants of type eye controllable, so in that case increase the speed to 1 or decrease it again to 0. We will repeat the same as you can see for the for each. So we're gonna find here again all the things are coming again to the same, but this time with the bedroom light. So here is it what happened step by step. First of all, we define it the abstract class, as you can see that one, and abstract class call it applicants, which is gonna provide shared functionality. In our case it was display details and an abstract perform function method. Then we had two interface, eye switchable and eye controllable. Both of them define contract for a specific behavior like power control, what we did like turn on, turn off, and setting adjustment. Even we combined the implementation for the smart fan and the smart light because both of them inherited from abstract class, which is gonna hold the shared behavior from applicants and implement the interface method uniquely. So then later on we used the main method to have something called it dynamically behavior. That one used the S type checking, which we are using for the first time. That one is type checking because we dynamically call interface method on the object. So this example demonstrates the power of combining abstract class and interface in three terms. First one, shared functionality. Abstract class provide shared behavior and enforce certain method. Second, multi-behavior interface allow unrelated classes to implement a specific behavior independently, as we saw in our case fan and the light. And flexibility and extensibility, you can add new applicants or new interface without modifying existing code. Let's have here an assignment. Gonna do all the same, but in your case gonna be class call it vehicle instead of applicants, and you're gonna have abstract method drive. Okay, and you just need to have two interface, one for refuel and one for electric charge, and you're gonna implement these in a derived class car one time, and the other time gonna be electric scooter, like what we did in it was a fan and a light. And please test your system by calling method dynamically using both the abstract class and interface. Now you have learned how to combine abstract class and interface to build a system that are both structured and flexible. In the next session, we will explore more about design pattern in C#, starting with the factory pattern. See you there and happy coding.